So in the previous bits, I kind of like monologued a little bit into like a bunch of the stuff, but this is kind of the like actual meat and potatoes of it. So I've kind of skimmed over a little bit of it, like the first part here and how it works, but going into detail on how it works was going to be interesting. So, how it works, there are a minimum of 3 participants involved in web environment integrity attestation. The web page executing in a user's web browser, a third party that can attest to the device a web browser is executing on, referred to as the attester, and a web developer's server which can remotely verify attestation responses and act on this information. So what they are describing here is basically the reverse of what happens when we access a website through HTTPS. So you've got, if we were to describe it in how we use the web today, they're basically doing it like back and forth, except they're not so focused on encryption like you are when you're accessing secure websites. So the other way around, you've got the web server that has the application you're trying to access. Then you've got the third-party certificate authority that basically verifies the certificate on the server. And then you've got the client, the web browser that grabs the information and goes through the verification process locally to double check that the certificate and process the verification from the certificate authority from on both ends. So now how it actually works is a web page requests an environment attestation from the attester with a content binding. The content binding ensures that even if an attacker intercepts an attestation, they can't use it to attest to a modified request. The attestation is a low entropy description of the device the web page is running on. So basically what they're describing here is kind of what already happens in some security frameworks that we've got currently with, various encryption keys and, periodic verification that the session is still the session you're in. Because as those packets and frames pass hands, if you have an attacker in the middle, either A, the only thing they can do is relay that, or B, if they try and modify it, they have to somehow hijack the session to tell the server that they are the legitimate host that originally started the session. Now with newer encryption methods and verification methods, it becomes much harder because there isn't a key being passed at all. So you have to try and decipher the encryption with keys that have not been passed between the server and the client. Now, what they're proposing here is passing information between server and client, or between an attestation server and the web server that the web page is on. So 2, the attester will then sign a token containing the attestation in content binding, referred to as the payload, with a private key. The attester then returns the token and signature to the web page. The attester's public key is available to everyone to request. So basically you're still passing keys here. Again, newer encryption methods do not require any passing of keys to encrypt anything. Both the server and the client are able to come to a key without ever passing information between it. It's just an open request. To dumb it down, it's the client sends a request, I want to open a session, and then the server's like, okay, here we go. And then they start a challenge where they have both generated a key together, but they never pass it on. They just encrypt and then pass, the information on the challenge on to verify that they are both who they say they are. There is no passing of keys at all. And you're talking these, keys are what? At least, in most cases, at least 128 bits. So you've got a 128-bit key that has not been passed, that both ends have to decrypt and encrypt a message. And here they're saying we want to pass a token and a private key over the network. Okay, so step 3, the web page returns this information to the web server. And the web server then checks that the token came from an attester it trusts and inspects the token's payload. It verifies the payload by verifying the signature with the attester's public key. So we've already got something similar to that already, that it doesn't require the passing of keys and tokens. And they're saying we're going to pass keys and tokens to verify a user on a system and verify the computer system that is accessing our web server. Why? We've got the technology already. It doesn't make sense to me. 4, optionally, the web server may call the attester's server endpoint to get additional low entropy signals. For example, to detect potentially hyperactive devices. So I don't get why that one. Okay, so what sign is in the signed attestation? The proposal calls for at least the following information in the signed attestation. The attester's identity, for example, so the attesting server would be Google Play. And then you've got the device over here that verifies with Google Play that it is safe. A verdict saying whether the attester considers the device trustworthy. So you are trusting Google's servers to tell the web server that you are accessing that your device is trustworthy. We've already got a system somewhat like that in play in Google Play. It's just you're not interfacing directly with Google Play's servers. If you have a device that is detected as compromised, you cannot access banking apps or anything of the like because of the safety net stuff on Google Play. Now, there are ways around it, and of course, there are going to be ways around this attestation with Google Play. But that would require a different kind of attack going on. You would have to basically attack the attestation server or attack the web server before you actually go through and execute this attestation so that it redirects to a different server that attests your device as being trustworthy. So Google, in essence, in this example, is setting themselves up as a central authority to say that this device is trustworthy, this one isn't. We're still discussing whether each of the following pieces of information should be included and welcome your feedback. The device integrity verdict must be low entropy, but what granularity of verdicts should we allow? Including more information in the verdict will cover a wider range of use cases without locking out older devices. A granular approach proved useful previously in the Play Integrity API. The platform identity of the application that requests the attestation, like com.chrome.beta or .mozilla.firefox or com.apple.mobile Safari. Or some indicator enabling rate limiting against a physical device. So we've already, they're talking about rate limiting traffic. So this comes down to basically what it sounds like to me is that they want to limit the rate of request. And they've already got that in place. Now, this limits the rate of request based on a central server that verifies, that says that a certain device is trustworthy, and then passes that on to the web server, and then tells the web server, says, okay, I will send you my information. Instead of the web server getting a request, sending the information, and the client being liable to verify that they are actually interfacing with the actual server and verifying certificates. Which basically turns this process around and saying, well, I don't trust the person accessing my device. So it turns into a zero trust system where you as the customer are accessing a service, and all of a sudden you are becoming the one being tested against to see whether you're trustworthy instead of the service that you're accessing. So we are to assume that like the corporate entity that we are accessing is trustworthy and we're not. I thought it was the other way around. I'm paying for your service, so I should verify you're trustworthy rather than you verifying that I'm trustworthy. I've already paid for the service, and I've given you the credentials and everything that I need. Now, we've also got two-factor authentication with like YubiKeys and so on that allow us to attest that we are the person that we are if we enable two-factor authentication through these like much more secure methods. But they want to do this on a client side where we verify that the person is who they are and also verify the trustworthiness of the device that they are using, which they don't say they want to limit devices, but in a lot of ways will limit the devices that can access certain web applications. How can I use web environment integrity? There are 2 steps to using web environment integrity for developers. The first step is to request an environment integrity attestation on the web page and to send it to the web server. So the web page is code that like you download or whatever, and then the web server gets a request. Now, many web applications run much of their code on the web server already. So they should already be sanitizing input and double checking all these things if they are configured properly. This, again, is another step that they have to configure. So if someone doesn't want to configure web environment integrity, then they lose out on the supposed benefits that this comes with. But we've already got technologies that give some of these secure benefits without needing to have another supposed standard or method to do it. It's just a matter of implementing it and configuring it correctly. So they've got a code snippet here. So let's see, get environment integrity expects a content binding of the request you're about to make. The content binding protects against this information being used for a different request. The content binding will be concatenated with ETLD +1 and hashed before it is sent to the attester. So are we actually sending the information or are we just sending the hash? Because if we are actually sending the information and the hash, then I believe we can, we should be able to figure out what method of hashing we are using in a man-in-the-middle attack to verify it. Unless we've already figured out the hash that we need, then we can verify the hash and the information, but we've got to verify the hash is the correct hash that we had originally. So they've got the code snippet that does that. And again, this just sounds like they're just reinventing the wheel of things we've already got. The attestation token is returned using an array buffer serialized with CBOR and signed using COSE. So RFC, they have different RFCs that they're referring to for this, which are basically, what was it? I can't think of what it means, but they are like, standards or implementations of ways to do encryption, security, and so on in technology for securing, encrypting, and other, IT functions. Further information about the contents of the attestation token will be found in the specification. Second step is on your web server where you verify that the attested information is valid using the attester's public key, and then make decisions based on the information reported. So you've got the attester and the web server that are both interfacing, that are talking to each other. And the client is sitting here like, hey guys, what are you doing? Oh, we're verifying that you're okay to access my information. That's all. It's fine. We don't know if you're trustworthy or not, so we have to talk to the council in order to decide whether we want to let you in. And let's say that, like, well, I've paid for, like, the service and whatnot. Are you saying I can't use it on the only device that I have? Well, not if you're, like, not insecure, which halfway makes sense. Again, you don't want an insecure, a compromised client to access your server. At the same time, it turns into a whole other can of worms of, are we limiting certain things? They claim to want to to allow older devices on, but when the devices aren't updated with these implementations, it starts to become an issue as to whether you really allow older devices on or whether you're just saying that to sound nice. And they're using all this big jargon to like talk to stockholders and say, here's why it's a good implementation and it secures everything, while leaving many of the users out of the loop. This is clearly not oriented to users. It's more oriented to stakeholders and to businesses and big businesses and companies. So let's see, none of the code below is part of the Web Environment Integrity API being proposed. This is an example of how you can verify the environment's integrity on your web server. So like, let's see, is it tested, trusted by me, return, let's see, yeah. A tester's public key is retrieved directly from the attester. When we then validate the attestation token using the attester's public key, we also check the content binding and replay the protection in the attestation. So we're sending tokens and keys across the network. So why? Well, if they're using like asymmetric keys, then it's a little bit more secure because you can't decrypt from a message that's been encrypted with the public key You need the private key to decrypt a message encrypted with the public key if you're using asymmetrical encryption. But that still requires like having somewhere where both keys are stored and then somehow transporting those across. Anyway. So I think I'm going to leave the next bits again. Another part, more monologue. Hopefully, like, it's a little bit more enjoyable and understandable this way, because I know people have done like 10-minute videos on this, like just like fluffing it up. And I'm hoping that this adds more discussion to it because we break down the actual details of it rather than just like, okay, here's a summary of what's going on. Here's a quick skimming. And then here, take action on it. It's like, here's the full information. Here's like an example, like for like thought and what's going on and like things we already have. And possibly like why we don't need it. I guess I'm doing less of the devil's advocate and more of like why. So original thing in first video, not quite there, but from a corporate standpoint, it does make sense. Anyway, next video will be around sometime soon. If you enjoyed the video, then like, comment, subscribe, feed the algorithm, boost the video up, share this video with your friends. If you found it informative or you just want to chat, I've got plenty of places in the description, Discord, Guilded, and what have you. Check those out, and I will see you guys in the next one.